Hello, hello. Testing, testing. 1, 2, 3. Hello, hello, hello. Hello, hello. Hello, hello. Hello, hello, hello. Cool. Right, where are we? So we're gonna start to put some maths in this. So yeah, I don't know what I'm doing, so it's gonna be very slow and painful. I may not get anywhere, but that's just the way the cookie crumbles. I guess first things first is we need we need two positions to start from, um, and then two positions we're aiming for. So let's do that. So, oh, this is all changed. Nice. I like it. Okay, so this is going to be electron A, and this will be electron B, and they are part of an atom. In fact, how do I rub things out? Oh, this one here. Ooh, okay. So let's call this these. Whoops. And we're going to have the atom. Whoops, that one there. And so the atoms are fired or presented inside some simulation environment, and the electrons spiral around them in their funny orbits. Um, and so I need an idea of having something that I can give a vector to, um, like so. And then the electron is determined by what the mass of the particle is, and all the other electrons around it. So actually, that's a little bit further on. I don't think we need to think about the atom as a whole yet, because we are more interested in a collision of, well, let's imagine for now, I don't know if this is true, that electrons can move freely um, within the confines of their energy field. So let's take this as the energy field of a particle. This presents some gravitational pull towards it, um, or maybe even not gravitational pull, but well, yes, okay, a gravitational pull. Let's just imagine that for now. And the electrons have movement from surrounding atoms, particles, but by default they would simply just be sucked inwards. But the protons attached to the center oppose the electrons. So these are negatives and the protons are positive. And so this happens. Let's model that first. And also let's make sure that that is indeed correct. So I think step one will be to just qualify that we are or we I am right in this thinking. So let's see. Given an given a particle, let's actually a periodic table. Let's have a look at the periodic table here. Let's go for something with two elements in it, which is helium. So, given a helium particle has two electrons, uh, a pro a helium particle has two protons because all electrons are balanced by equal amounts of protons. Uh, I don't know if this is true. I can't remember, but we'll just say these things and then, or let's say, are the following points correct? If so, I will lead on to other questions. Let's do that. A helium particle has two electrons. A helium particle has two protons because all electrons are balanced by equal amount of protons. A helium's neutron, neutron? A helium's nucleus has I think, yeah, this is actually wrong, I think. So let's can you describe to me the most important, well, how many electrons, protons, and neutrons does a helium particle have? Can you explain to me uh, a set of rules around quantifying these for other elements? For To add context, I am trying to simulate, or trying to create a simulation for electron collisions, and I'm just starting off at the basics of understanding what makes up a particle. I mean, we know this stuff. We've been through it a million times, but I also forget if I don't use this stuff for a couple of months, it's gone. Um, right. Uh, for example, you could list them in the following manner. Etc. Let's just see that. So it's saying the atomic number Z, the atomic number of an atom is equal to the number of protons in its nucleus. So if I go to the periodic table, the atomic number is 4, so there are 4 There are 4 protons in its nucleus. For example, if an atom has 2 protons, it's a helium atom. 2 protons. So it's the top left number, okay. If it has 6 protons, it's a carbon atom. Let's see what carbon has. Here's carbon, there's the 6, okay. And let's look at another table as well, just so we understand. 1, 6, I see, so it's the big old number. So this atomic number also determines the number of electrons in an electrically neutral atom, where the number of protons equals the number of electrons. So it gives you the number of both protons and electrons. Atomic mass. The atomic mass of an atom is equal to the number of protons plus the number of neutrons. That is, A is equal to Z, number of protons, plus the number of neutrons. You can determine the number of neutrons by subtracting the atomic number from the atomic mass number. So neutrons equals A minus Z. So if we go to this here, this doesn't have the mass. Let's see. Here's the mass here. So Z is equal to 2, and Z is the atomic number, and then we've got the atomic mass, or A, is equal to 4.0026. Because the atomic number is 2, Z, let's see what it says it as here. It's saying N. So E equals Z, and Z equals it says atomic number. The atomic number of an atom is equal to the number of protons in its nucleus. Protons. So protons equals atomic number. If an atom has 2 protons, it's a helium atom. If it has 6, this atomic number also determines the number of electrons in an electrically neutral atom, where the number of protons is equal to the number of electrons. So is equal to E. Okay, and so these are the electrons, these are the protons, this is the atomic number. Okay, so it gives the number of both, and so it's saying the atomic mass A is equal to the number of neutrons. So N neutrons is equal to the atomic mass minus Z. Was that right? Yeah. So in this case, if A is 4, then let's just do this. 4.0026 minus 2. Therefore, the amount of neutrons, or N, let's just do N, is equal to 2.0026. That's strange. For example, let's consider helium. A helium atom has an atomic number Z of 2. Yep. So it has 2 protons. Yep. In its neutral state, a helium atom also has 2 electrons, equal to the number of protons. Most helium atoms have an atomic mass number, A, of 4. Most helium atoms have an atomic mass number of 4. The most common isotope of helium, meaning they have 4 minus 2, which is 2 neutrons. So a helium-4 atom typically has 2 protons, 2 electrons, and 2 neutrons. Keep in mind that this is simplification and there are isotopes which are variants of a chemical element that have different numbers of neutrons. For example, helium-3 is an isotope of helium that has 2 protons, 2 electrons, but only 1 neutron. So, given that the atomic mass is a decimal number, do we round, sorry, is it typical to round up or down when knowing how many neutrons an atom has? Furthermore, how accurate is this model? Is this merely a way of teaching the structure of an atom to kids, or is this to, well, people who need to learn easier, or is this something taken quite seriously and used in simulation calculations? I need to do that seriously. The atomic mass of an element that you typically see on the periodic table is the weighted average of the atomic masses of the isotopes of that element. It takes into account both the mass of each isotope and its abundance, how common it is. Since it's an average, it often ends up being a decimal. When determining the number of neutrons in an atom from its atomic mass number, we are typically referring to a specific isotope of that element, not the weighted average. So in practice, you don't usually have to round because the atomic mass number of a specific isotope will be a whole number. However, if you are given the average atomic mass and asked to determine a typical number of neutrons, you might round to the nearest whole number. Understand that this is a simplification. The actual number of neutrons in an atom of an element can vary depending on which isotope it is. The atomic model with protons, neutrons, and electrons is not just a teaching tool, it's the basis for the current understanding of atomic structure. This model is taken very seriously and is used in calculations across physics and chemistry, including in simulations. However, it's important to note that this model is a simplification, and for more advanced or specialized applications, you will need to take into account the principles of quantum mechanics, which provide a more detailed but also more complex view of atomic structure. For example, electrons in an atom don't have definite positions and speeds, but rather exist in clouds, called orbitals, where they are more or less likely to be found. Quantum mechanics also explains why electrons occupy specific energy levels, and why atoms form the types of bonds that they do. Yeah, cool. So going back to our requirement here, um, what do we actually need to know? Well, we need to know the atom because, or the particle, because this is giving and exerting force um, both through the pull of protons positive to the negative electron, and one would assume through gravitational force itself, though it's interesting because I think this is the problem with quantum physics. Is this something to do with it doesn't use gravity as a force? So I guess it's not a force, it's an energy level, isn't it? So maybe that's why that doesn't quite make sense. I don't know. Oh, gosh, why are you yawning so much? So let's start by adding this atom, which will have which will have protons and neutrons, and then we'll split those up after. Um, when we get to that point, we can start quite basic, I think. Yeah, so let's do that. Let's go add a new item, and we'll call this the atom, or the particle. Well, it's an atom. Let's call it an atom. Uh, yep, atom. And we're going to say it has protons and neutrons, or even we could say atomic number. Atomic number is always an integer, is that correct? Yep. Okay, atomic number is always an integer. And then we're going to have the atomic mass. It's going to be a float. And what we could do using those is say that the protons is equal to the atomic number minus, no, it's the neutrons, isn't it? So it's protons equals atomic number, that's correct. And then the neutrons equals the atomic number divided by, no, Z is the atomic number, so it's the atomic mass minus the atomic number. And then we want to round this to the nearest number. So Python round number to nearest whole number. Let's just start as we and we develop our understanding as we go along. Round. Let's do that. So I think this is the place where we need to do our first test, right? Because I want to know that when I do an atom, the neutrons comes out correctly, and furthermore, that the electrons is equal to the protons. I think that's what that said. Where the number of protons equals the number of electrons. Okay, let's do that then. So let's write some tests, and we'll call this the atom. And then we'll call this atom underscore test dot py, something like that. Given the following class, can you write a unit test, a Python unit test that ensures that if an atom is defined as helium, then the electrons, protons, and neutrons are set up correctly. In fact, atomic number equals atomic number, and the atomic mass equals the atomic mass. Let's put that in there instead. This should give me an example of how to unit test. I have done unit tests before, I just can't remember how to do them now. I think I've actually got a GitHub of examples, to be honest. Um, Good. Okay, so it's doing it as a thing like that. Unit test sounds good. I think that's the one I've done before. And let's rename this test atom. I don't think I've ever done it as a class. That's good. Unit test, and that means we've got to add that to the requirements. There you go. From models.atom import atom. That's exactly right. Class test atom. Oh, why am I doing that? Let's just put in 2602. Where did I get that? 002602. Okay, let's just put that for now. Helium protons is 2. The number of protons in helium should be 2. The number of electrons in helium should be 2. Helium number should be approximately 2. Should be rounded to nearest whole number. Which is 2. Okay, and then how do I run this test? In this test, we're rounding the atomic mass to the nearest whole number to calculate the weight. But remember, atomic mass on the period is a weighted average, and rounding it might not always give the exact number of neutrons for all isotopes. You can run this test in a script file or a Jupyter Notebook cell, and it will print out whether the test failed. Okay, how do I run the unit test? Whilst that's doing that, let's go and install. Let's see, install from requirements.txt. So it's installing the unit testing framework, and then so I think actually though this has a way of configuring testing framework. So let's see if we can get that to work. In fact, it might just be Test Explorer. Might be obvious. How do I configure Visual Studio, not Visual Studio Code? Whoops, didn't mean to do that. Wasted a token there. Stop. Studio Code to use the Test Explorer to run Python tests. Is it even possible? Um, well, so I thought that might be the case, but clearly that's not working. But good to see that unit test is thing. I think I used PyTest actually in my last one. So let me go and check out my GitHub here because I'm sure I've done this before. I'll run it manually, make sure it works, and then hopefully we can go from there. So these are tests that I've done before. Yeah, PyTest I was running. Okay, and a test looks like what? Let's see. ML bit sounds good. Tests. It's just a function, and you assert. Okay, so if that's the case, aha, I see. I see. I see. Okay. Um, fine. Run tests. Let's see. Python. To run tests, Visual Studio. So if I build it, what does it mean? What does it mean to build Python, I wonder? Build your solution. Hmm, not really sure what that means. Maybe there's properties for this. Nope. Uh, it's definitely got the understanding of testing, but I don't think it's picking it up. The I have used your test. It's nestled inside a tests atom.py file. The environment is running inside the root directory. The test explorer is not seeing my Python unit test. Aha. So it needs to have test.py, which is fine. I don't know how you build a Python solution, to be honest. Python. Um, refresh the test explorer. Check your Python. Make sure that your Python environment is set up correctly for your project. You can check this in the Python environments window. Ensure that the Python interpreter selected matches the one you're expecting and is correctly configured. Python tools. Let's just make sure that that's actually installed. PTVS. Let's see. Definitely there. PTVS, Python. I mean, not anything too obvious there. Let's see. Well, search paths. What are the search paths? Add Python path to search path. So one would assume that was already done. Like, what does it mean to build your solution in terms of Visual Studio and Python? I'm gonna write a token soon, aren't I? In the context of Python, a compiled language like building doesn't apply in the same way. Python is interpreting, yeah. In Visual Studio, when you work with the Python project, there isn't a build process similar to when I mentioned building your solution, this was misleading for Python projects. In a Python project, your code is ready to be run, so it's syntactically correct. Therefore, building a solution in the context of a Python project in Visual Studio can simply mean saving your files, ensuring that there are no syntax errors. Python unit tests in Visual Studio. Once you've written the test case, you should be able to see it in the Test Explorer without needing to compile or build your project. If it doesn't appear, make sure your Python environment is set correctly and that your unit tests are structured correctly as per the unit test modules requirement. Well, regarding why don't you tell me if what I have is compatible? I have a solution with an environment folder called I have a folder with an environment folder called .vm. The environment is activated one level outside of. Okay, then there is a tests folder. In that is an atom folder, and inside that is this class, this file, test atom.py. It has the following test inside it. Yeah, let's see if I can run this file as well. Let's start, I guess. No, that did not work. So how do I run this file? Maybe I can run it here. Start with debugging. Here we go. Ran one test. Okay. Press any key to continue. The test itself runs fine, but the test explorer does not appear to pick up on it. Okay, let's see if it helps here. Looks correctly structured and should work fine, run directly. However, it might not appear in Visual due to some configuration data. In general, Visual Studio's Test Explorer uses Python's unit test framework as the default test framework. If you're into detecting a test, the following are some of the things you could check. Ensure your Python environment is correctly configured in Visual Studio. Needs to be able to access your Python interpreter and install packages in order to discover and run tests. If you created a virtual environment, ensure that Visual Studio is using that environment for the project. It is. Although, I wonder if I need to also just install unit tests globally that might be the case actually. So if I go, let's go pi. Yep, we've got it here. And I want to go pi pip install unit test. Could not find a version that satisfies the requirements unit test. Updating pip first. Okay. Kind of interesting. Mm, it's clearly not running them. Let's just comment this up for a second. So, so now I've installed that globally, but actually, no, I haven't. I haven't installed it globally. And what was this unit test? Yep. And I'm trying to install that. Couldn't find a version that satisfies the requirement unit test. Unit test. Hmm. Python module automatically discover test cases in files whose names start with test and not inside any direction that is a package, i.e. it has a init.py. So which I haven't found each direction. Ah, okay, that's interesting. So let's try that. I think I have seen this problem before. Maybe even in Visual Code, it may have also had this problem. It makes me wonder now if that's still required. And there must be some settings around here that say something about where it's going to be run from. Hmm. I don't see that anywhere. Diagnostic mode. Type checking. Strict. Stubs path log level. Open files only works with diagnostic mode. What's this one do? Run failed tests. Open playlist file. Don't even know what that is. Group by, expand, options. Solution-wide run settings file. Configure remote test environments. Run test processor architecture. Run tests in parallel. Player sound columns. Options. That's where I just was. And I think this doesn't have any options here. Unit test is not in this list, interestingly enough. So I wonder, actually, what was happening? I wonder what was happening when I was actually trying to install this with unit test in there. Maybe that's not the correct name for it. So install from requirements. Error, could not find a version. Unit test. Yeah. So package unit test. Pip unit test. Let's try that. Unit test 2. Backport of the new features adding to the unit test framework and is tested to run on Python. So use unit test 2 instead of unit test, simply replace input unit test with input unit test. It's interesting how it won't let me install that. Requirement requirements.txt. You have at least two ways to go back to your original structure and make it work. The first one is adding in your test structure at all levels, also a test folder that you have missed, is to transform your code into a Python package, adding a setup.py so that your app will be instantiable with pip. Install your package in the local interpreter and then run the test in PyTest and call directly PyTest instead of Python unit test. So maybe that is actually a problem as well. Probably don't need it. Uh, let's just see if this actually runs. Start with debugging. Yeah, it's definitely there. Still not finding anything. And I don't, yep, I don't think that works, no. Oh, yeah, I don't know. Uh, Configuration manager. Properties. If anyone's watching and knows how to get Visual Studio to run the Test Explorer for unit test, that would be awesome. Just wasting a lot of time now. Let's see, Visual Studio Python unit test explorer. Unit tests are pieces of code. Select the test framework for a Python project. Visual Studio supports two testing frameworks for Python, unit test and PyTest. By default, no framework is selected when you create a Python project. To specify a framework, right-click on the project name in Solution Explorer and select the properties option. Aha! We've got it. This opens the project designer, which allows you to configure tests through the test tab. From this tab, you can select the test framework that you want to use. Test tab. Test Explorer. In fact, I'm gonna delete that now. So it says, yeah, by default, no framework is selected. Specify framework, right-click on the project. This opens a project designer, which allows you to configure tests through the test tab. From this tab, you can select the test framework that you want to use. For the unit test framework, the project's root directory is used for test discovery. This location, as well as the text pattern for identifying tests, can be modified on the test tab to use specified values. For the PyTest framework, test options such as test location and file name patterns are specified using the standard pytest.ini. Once you've saved your framework selection and settings, so I wonder if I put this one in here, like just plop it in the and then run this. Doesn't appear to have picked it up yet. test. Configure remote test environments. Auto detect. Let's try reopen this test explorer. Still not doing it, but that was so interesting that we found that root directory dot test star.py test. Open local folder. Click the show all files icon to show all files in the current folder. Navigate to the python settings.json. Add the test framework to the settings file. Navigate to the python settings.json file within the local settings folder. So that's not actually there, is it? For unit test framework, if the fields unit test root directory and unit test pattern are not specified in the Python, they are added and assigned default values of dot and test.py respectively. Okay. By default, Visual Studio identifies unit test and PyTest as methods whose names start with test. Yeah. See the test discovery, do the following. Open a Python project. Once the project is loaded in Visual, right-click on your project in Solution Explorer and select the unit test or PyTest. Open the project is located. Right-click your project in Solution Explorer. Yeah. And select the unit test or PyTest framework from the Properties Test tab. So here's my project. Properties. Done that. Saving it. After the framework is selected, right-click the project again and click Add New Item. Add New Item. Then select Python Unit Test. Add New Item, then select Python Unit Test followed by Add. This has changed a bit, hasn't it? Add. Test. Show all templates, here we go. Python Unit Test. Okay, yeah, so it does do that. This creates a test file with code that imports the standard unit test module, derives a test class from and invokes unit test.main if you run the script directly. Save the file if necessary, then open Test Explorer with the Test Explorer. Searches your project for tests and displays them as shown below. Double clicking a test opens its source file. Alright, well, it's not quite working. Yep. Well, okay. Maybe then, maybe just maybe, restarting Visual Studio might help. Let me just do that. That might actually do it. Mm. Oh, hang on. Yes, it did. Oh, hey. Alright, cool. We got it working. That's awesome. Let's get rid of this then. I don't know what that is. Aha. So it can't find it now. So I wonder, let's, I tell you what, this is a bit weird. Let's just try closing this again. Runs partially unknown. Simulation.run. Well, I don't actually know what, it doesn't run anything, that's why. None. Okay. Type of update is partially unknown. Type of update is frame unknown none. Update is gonna be none. Frame is what? Let's see. Integer. And then select all open figures. Type of show is partially unknown. Type of show is unknown. Yeah, I don't, I mean, I don't have that ability, so let me just go and turn that off, because I guess it isn't going to work, is it? Let's go back to options. In fact, I think if I just go here, maybe. There was somewhere I was finding it. Maybe this? Nope. I was configuring all this stuff somehow. Where are we? Python, run tests, configure, unload, tools, Python. Oh gosh, where did I find that? Options. It was maybe this? Aha, could be this. No, oh damn, where did I find this? Damn, I was looking at something. It wasn't properties here, was it? No. Don't know if it was that. No. Where did I do that? Properties, no. Maybe this one. Nope. Wow, I can't even remember now. Edit, tools, options, test. Ah, here it is, Python, debugging, um, analysis. That one, basic, okay. So this will be a none. Good. And then let's try and get that test explorer up again. It's not finding that, and so I wonder now if I just restart, now when anything different happen. And if not, then we'll try the init thing, and then if not, then we'll just we'll try and add them to a less deep structure, I guess. Although I'm sure there's a way to configure it. I guess maybe it's not worth it. One warning. What's the warning? No test is available. I see. It is interesting, isn't it? Visual Studio adding test folder structures. Python. So if I were to copy this out and move this again, is it going to be discovered this time? And what about if I close and reopen it now? Just doing a little bit of debugging because I'm quite interested to get this working. No test is available. So it still doesn't find it. So so I wonder if I go and add this now, Python unit test. We'll call this test atom 2. Zero tests found. Zero tests found in Plectrum model. Make sure that executors are registered and annoyingly, because I can't actually see the warnings it's coming up with. See. Here we go. And platforms and framework version settings are appropriate and try again. No test is available in Electron model. So I think it wants, maybe it wants this init thing. So let's try that. Empty module. Let's just try underscore init underscore py. Let's do that. Yes, look at that. That's interesting. So if I now delete that, how quick is that going to pick that change up? Let's see. Let's try now delete that. I think this is a refresh as well. No, it's not. But it seems to be testing this. I see. Isn't that going to work? Yeah, it's working. Okay. So does that mean that if I actually delete that, then it'll stop finding it? Yes. Okay, so it needs the init. Alright, we've got it, guys. We've got it. Oh, yes. Good. And it's interesting too, because why does unit test need underscore init to find the tests in Visual Studio? If I have a subfolder without underscore init, it doesn't find the test. Serves a special purpose in Python. It needs it's needed to treat a directory as a package. Packages in Python are simply directories that are used to organize related modules. In older versions of Python, in order for a directory to be recognized as a package, it had to contain a special file named init.py, which could be empty. When Python encounters a directory while importing that contains a file named, it treats that directory as a package and is run when the package is imported. In the context of unit test discovery, unit test uses the presence of init to find testable Python scripts. When you run unit test, it recursively looks for Python files in the directory specified and any subdirectory it contains. If it encounters a directory without an init.py, it will not recognize that directory as a package and it won't look any further into that directory. Even though in Python 3.3 and later it is no longer strictly necessary for a directory to be treated as a package, many tools and libraries, including Visual Studio's test discovery, continues to use its presence to recognize a directory as a package. So for max compatibility, it's often still a good idea to include in your Python package directories. Do note that the file can be empty, it just needs to exist. So it's also saying, or recommended, that I put that in there too, which I think is quite funny. So let's run this and let's see the output. And testing atom, test helium atom, and that works. Cool. That's awesome. What I'm going to do is I need to take a quick break. I will add another point 2 onto here, and I'll see you soon. Bye bye.